Hi, everyone. Thank you so much for joining us today. This is the Graph and ML for Supply Chain webinar. If that's what you signed up for, you are in the right place. Just wanted to let you guys know that we will be recording this webinar and it will be online and sent to you via email after this is finished. Also, please submit your questions to the Q&A box or to the chat throughout the webinar, and we will have some time set aside to answer those. And Scott, when you're ready.
Fantastic. Well, thanks everybody for joining us. If you've been following us along, then we've got a couple of them that are out there you can go check in on. We have been reading the comments for folks that signed up, and it sounds like we've got some folks that are interested in new graph sort of 101, so we'll make sure we talk to that today. And my name is Scott Heath. I'll be one of the tour guides, and I have with me Graham.
Hey everybody, I'm Graham Gansel. I'm the head of data science here at Expiro. My experience is in deep learning, and my PhD is in physics signal analysis.
Fantastic. So what we have on tap today then is we'll give you a quick couple slides here on who Expiro is. If you don't know us, we are consultants, and we use products to help our customers build products, whether it's modernizing your current software and whether we use machine learning, and in this case, graph. We help our customers build applications. We can also help you with roadmaps and assessments and rapid prototypes, or something we'll touch on a little later. And our goal here is to bring education and experience to our customers, whether that's through these things or through training. Many of the products that are out there today, if you're interested in graph, and there's new ones for Neptune and Cosmos DB, but these are kind of the big ones that are out there. Neo4j, DataStax, Janus Graph, and Titan, and then our application visualization partners with Keylines and Link Curious. And really what we strive to do here at Expiro is make sure that we share all the different products, which ones have pros and cons, they all do, and how we can best use them. But that's a little bit about the kinds of technologies that we use at Expiro, and we'll talk on some of those today. The next one then is big customers with hard problems. Today our topic is supply chain. We talked before about Customer 360 as well as what we're doing in fraud, and our goal is enterprise class software with graph and machine learning, and then today we'll focus in on what supply chain looks like. But again, we've been there, and we hope to bring that experience to you guys on the phone. And this is the last in our series for this go round. Those of you who joined us for the first two, certainly come view those online if you did not, and that's where we are today. So without further ado, let's jump on in. And so on the topic today, we're going to talk about optimizing, whether it's logistics in the source, the material, the manufacturer, or the transport. And these are all aspects of what most people refer to as supply chain. And we're going to talk a little bit about those, how graph and our friends that do ML can help us make that better. I think one of the most crystal clear elements of what we see in supply chain is that a singular increase, whether it's creating better paths for materials coming into manufacturing, whether it's the actual lean manufacture itself, or the logistics or the routing, simple percentages can have a huge impact on the bottom line. And ultimately, that's why a lot of times the supply chain is one of the first items that people, when they mention graph, comes to mind. There's a lot of capabilities that we can use graph for, but the bottom line here is, you're either cutting costs, in some case, or driving revenue is very straightforward in the supply chain. Now, how do we do that is typically more difficult, and in some cases quite complex, and that's really kind of what we have on the table for today. And again, it's this full concept of everything from source material, whether it gets in now that satisfaction index and can manifest itself all the way through SKUs or warehouses with bills of material, can see itself in pricing, transactions, and then all the way out to frustrated customers that can turn into chargebacks. All of these have an ecosystem that are very important, but the great news for us is we bring you good news, and that is that graph and the machine learning and visualization can use these common traits, like the attributes for a graph engine, can really help us to unlock this business problem. And that's what we see now are things like these transactions and whether it's service orders or customer orders, the other kinds of things that we can do, et cetera. And then ultimately when we get to the last leg of transport. So now we start to think about, well, okay, Scott, we see that graph is interesting. We see that it might be able to help us. And these are just a few of the visualizations of where we start to go now, which is this concept of structures in graph. We can see how a bill of materials may have, whether it's a Sankey chart or some of the traditional items that we'll see here, but how can we start to use this graph element, some of the nomenclature to start to do those things? But where do we start and how do we do those kinds of things? I imagine most folks on the phone are SQL, pretty heavily steeped in SQL, and that's where we'll go next. So our first premise is graph is really good for supply chain. And if you'll follow me now into this path, what we start to realize then is whether our SAP bill of materials or customer master or bill part master, whatever it may be, we have lots of data sources, and we know that your current world is complex to say the least. And in this model, what we endeavor to say then is whether it's a single SKU or it may be a single customer, our goal before we get into the graph methodology over here on the right is to start to map that information. And the good news again is that we can leave most of that data where it sits inside of those source systems. And our goal here is to create pointers to the data schema, start to create this single path, if you will, into a customer or an order or a shipping owner or a manufacturer. And we start to take these different arms or what we call branches of the graph as we get into this entity resolution. And if I'm a customer and my name may be Scott Heat, I may have a different record in all of these different systems. I may have specifically a customer record in the billing system. I may have it in the ordering system. I may have lived somewhere previously, and I may have different orders and names. But the goal here now is to start to create this single view, or as we call it in graph, an entity. And what we do here now is we start to resolve that. So there may be hundreds of my records that are really just one of me, and I can start to use machine learning now to do some smart algorithms to start to put together. There really is only one Scott Heat, and in fact, he has lived in different locations, and he perhaps has ordered many different things in our supply chain. And now we start to build the graph. And our goal here now is all of the aspects of whether it's a part or a customer is to start to build this graph, and whether you use one of the products I mentioned earlier or something along those lines, we start to build this three-dimensional view in a graph traversal so that we can start to build applications. And really our goal in all of these applications is that poor customer at the top who doesn't really care too much about graph and technology and Oracle, they just want to solve that problem. And those are the people who sit in the upper right-hand corner, which use these dashboards and applications that we build. And so really that's what brings us today to how these applications are used. The next slide is for the technology folks that are in the group. This is a great slide that shows kind of that complex world of whether you're grabbing that data and you're using an ETL product, or you have a data lake or a Kafka queue, and some of you may have moved out onto the cloud, et cetera. And really what this is designed to show is that our world is complex. We get it. You have many different products that are out there, and graph in many cases sits now on top of many of those other products. And ultimately our goal here is to create those applications way off on the right. This is just more of a technology view of that picture. Now, when we talk about how we get into a graph, if we all have the premise that graph is good, Scott, but how do we really get there? That next stage now is starting to take that data source, as we talked about previously, each of these branches in what seemingly could be unrelated graphs, and we start to put them together into one singular graph. And this may include everything from customers to bills of materials to parts to subgroups to transport to shipping and lading and all those kinds of great things that are out there. The goal now is to create this single view of the data. So whether I'm tracking or I'm in a customer 360 environment and I want to share with the customer where their order is, It's building that graph is where we start to unlock the true power of what we can do with graph. In that node, when we talk about master data, if we take that record, and what we see over here now is an unresolved yarn ball, if you will. And what that means now is I have 165,000, and this could be part records or customer records or bills of material, et cetera. And ultimately, until I resolve those, it does exactly indeed resemble that environment, which is a great big yarn ball. What we start to do now is with machine learning and other techniques, we can actually resolve it down to a more known sphere. And when I meant three-dimensional in graph, I meant three-dimensional. We can now see potentially in this case, the connectivity, if you will, which could be a customer, it could be that bill of material and the subparts in red. And then the other things were related, perhaps, that were other orders that Scott Heath perhaps had ordered. But our goal now is to start to put that into something that I actually care about, as opposed to this disparate set of data. For those of you guys and gals that are SQL familiar, graph's a bit different. We can actually now start to create a much flatter view of that data. And for those of you that are a bit more technical, this is more of the logical view of what a data model is, but that is our physical model inside of a graph. We can start to query a product. In this case, it's a person or a friend, and I can start to build some very simple queries inside of a gremlin, which is a query language inside of graph, which could potentially be 1 or 2 lines. And the point of that is to make it simpler for us to query, simpler for us to view it, and then also the time as well as what goes on. And this is what it looks like for those of you, again, that are SQL-based, building a 30 table outer join, and then finally getting down to the final aspect of finding out where is that order, where are the products, and what does that look like. This is what it looks like here in the forefront for what it might look like in a gremlin query versus what's behind it, which is the known and typically difficult version of what's in a SQL. And again, now we're suggesting that there are some advantages in graph. One of those is the speed. The second of those is what I would call the simplicity of the data model. And the third now is just the simplicity of the querying or the indexing. This is designed to show us, in this case, a true graph data model. In this case, we can start to do things now that it's in a graph data model, which is in this instance, we have Marvel, which is the franchise or the product group, perhaps. And there's also then a Iron Man toothbrush. With our series of activities inside of graph, I can start to do things like recommendations. Very simplistically, I can suggest that with a certain date in the year, which might be close to back to school, if that customer is of a certain age range, there's a high proclivity that they may indeed purchase an Iron Man toothbrush, so I want to recommend that. I can also use these items over on the right for shortness of path. I may want to look for other customers that have bought these things, similarity of this customer to other customers, or dependencies in this case might be something that we see in logistics or transport. But the goal now is with this very flat graph data model, I can start to do some very important things as it relates to supply chain. And these are exactly that. I can start to now query and do some very intelligent things once I have this graph data model. Things like dependencies, that clustering, the similarity, matching, this concept of flow, and then centrality. And all of these are very, very indicative of what we can do inside of supply chain. They all have impact, as we had mentioned before, but now we're standing on the edge where graph can really help us get there. Now, the picture on the left could very simply be someone's supply chain. It could be a series of products that have been ordered. You may see things in the bottom or the top, but quite frankly, it's quite unruly for us to visualize and for a human to really interact with that. And with that, that really brings the need for what we see on the right, which is to put it into a concept that, again, a human being can organize visually, somebody who doesn't perhaps know all of the ins and outs of logistics or supply chain, something that they can react to and actually respond to and create an action. And that's really where we're going here, is to help human beings interact with these types of things so we can use that machine learning, et cetera. And so with that, we come to Graham's section, which is if graph is good, graph plus machine learning must be great. Over to you, Graham.
Thank you, Scott. Before we get started on the heavy-duty machine learning, I wanted to make a note here of Expiro's awesome list, so-called awesome list of graphs in machine learning. So that link at the bottom of the page, you can go over there and visit a bunch of resources. There's open source code. There are a bunch of articles about how to implement some of these ideas we're going to talk about today. So we're going to talk, before we get into heavy-duty analytics, let's talk about how you even get your data into the structure to do those analytics. And that's what Scott touched on beforehand. So this is what that really looks like. So we have the visual path of the canonicalization of supply chain data in this diagram here. So we start with a huge group of databases on the left-hand side of this diagram, and we move through the pointer record that Scott touched on, and we have our machine learning entity resolution system canonicalize our data for us. And I'll touch on this system in the next slide, but before we do, canonicalization is the collapsing of information into unique properties. So in the case of a supply chain, that would be warehouses, just distribution facilities, carriers, things like this. So if you had several different databases like we have on the left with purchase orders and work orders, maybe you have duplication between those data sources and you want to resolve that information. And as we move past that same as graph over the right-hand side of this slide, we actually see now that we're able to drill down into those nice detailed views that we see of our supply chain. On the next slide, we see the description of that machine learning system. So we have a series of steps that we take there to resolve your data records. In the box number 1, we see a set of strings. Again, these would be from your regular data sources. Could be SQL, could be flat files, could be anything. We use a system called logistic regression to actually learn which one of those fields are most important and how they relate to each other. That's called supervised learning. And then finally, we cluster them into groups that are groups of sameness, and that's how we build that same as graph. If you're not into machine learning, you can just take this slide and say, okay, we start on the left with all of our old legacy data sources, and we get to, on the right-hand side, beautiful graph and ready for insight extraction. One more unsexy thing before we step into the analytics world, and that is, can we use our old data in legacy form, maybe even paper form, to perform these machine learning tasks and these data science tasks? The answer is yes. In fact, we have done this for several customers. And the reason that I inserted this slide here today is because we've been in discussions with several potential customers who said, look, we can't even get our data in, let alone get it into a graph. So I would just like to mention quickly here that indeed we can use modern deep learning techniques to extract information from scanned documents. So if that's something you're interested in, please get in touch with us. With that, we'll go into the sort of analytics workflows that we do here at Expiro. So on the next slide, we see a set of fulfillment nodes. So I say nodes because, again, these are organized as a graph. The lower left-hand side of this slide is an example of what that graph would look like. And I'm describing a task here called nonlinear clustering. This is completed by a variety of unsupervised learning techniques. And the benefit you get here is if you're trying to evaluate your current fulfillment process or your current supply chain state of being, we find that many customers can't even understand what business they're doing currently. So this is one of the ways that we try to help our customers get in touch with their business. So in this case, it would be very easy to grade all of your shipping, let's say warehouses, storage facilities by average revenue per year. But that's only one factor, right? You don't want to compare your facilities simply on one metric. So what we do at Expiro is we take a high number of metrics and we actually build a system, this unsupervised learning system, which grades facilities or ranks facilities according to a holistic view of all of those metrics, right? So I have some listed on the left for common supply chain applications. So that would be maybe time to ship, total volume moved. You could have thousands of these attributes, and each one of these nonlinear clustering techniques. Once we do that, actually, before we do that, let's touch on, maybe you don't have those metrics calculated. So right now, we can also do metric prediction. So I think most business analysts and business intelligence services can calculate facility metrics for you, but most cannot accurately predict those metrics into the future. So here on this slide, we have the description. This is an architecture slide. This is a diagram of a real system that we built, which leverages a deep learning technique to generate predictions about facility metrics into the future. And this is conditional prediction. So we actually can predict these metrics based on external events and internal events and react to that within the supply chain. So for instance, let's say there's a flood. We can predict what is going to happen with warehouse 732 because there's this external event that's affecting the supply chain. Internal events would include things like sales, promotions, things like that. So we can, before we go offer a sale to the customers, we can predict which facilities are going to run out of product first. That's one metric we can calculate, again, among thousands. And then we have mixed metrics, right, or mixed conditions. So if there's port congestion, how do we know what's going to happen with customs, with clearing our goods into the country, right? So we can predict those things based on data from your company. And then, of course, you see the outputs there. So we build an updated fulfillment graph so we can move forward with the rest of the techniques we'll talk about today. So this is a detailed slide. I won't spend too much time on this, but in step number one here, we're extracting data from the graph. This is the fulfillment graph again. And then step number two is the extraction. And those links between the nodes there are performance under certain conditions. Again, those conditions are things that could be external events, could be internal events, or those combined conditions. Step three, we build the so-called feature vector. And step four, we input that into our graph deep learning system to predict how those metrics change under those conditions in real time. So we have an example of that here. So this is a hypothetical supply chain, including various manufacturers, distributors, shippers, and then customers. So this is a computer manufacturing, delivery, assembly, and retail sales fulfillment pipeline. And we're looking at one particular wholesaler here, which is CWI. And we say, okay, given the current state of our supply chain and all those metrics we have from the data that we have about our supply chain, let us then predict either the metrics that we discussed before or where that particular node in the supply chain graph, in this case, again, a wholesaler, exists in their life cycle. And we can begin to make predictions about how that particular wholesaler will evolve over time as they continue to exist in our supply chain. Again, this is using that graph deep learning technique I showed on the previous slide. So a task that we've done time and time again is showed a dynamic supply chain routing algorithm in a variety of techniques. So we could do this with using machine learning or not using machine learning. The common thread here is using graph to extract information about the current state of the process. So this slide that I've shown here is actually optimizing our supply chain using routes, shipping routes, which don't currently exist. So this technology is called graph autoencoding. And we can actually predict new routes that would save you whatever cost you're looking to optimize. So those costs could include things like total expenses burned by the company. They could be the maximization of revenue based on products sold, or they could be something more specific, like for instance, gasoline burn or diesel burned by trucks shipping goods around the United States. So you can see on this slide that we've predicted now the shortest path between these two facilities, and in fact, just cities in this case. Additionally, we can predict weak links in your supply chain. So we can, if you have on the left-hand side of this slide, we see the original supply chain. There in the middle, we have a single point of failure, which is one storage facility, one warehouse. And sometimes it's hard to notice these things. It will never be this, as you know better than we do, it will never be this simple in real data. It will never be this simple in real application, real supply chain. In reality, there would be thousands of these nodes. And we use a machine learning technique to predict what type of nodes would be best suited to fortify the supply chain. So this algorithm hunts out weak links, and it suggests actions that will increase the robustness of the supply chain under, again, certain conditions. Like for instance, if there was an earthquake in the city where warehouse 1 existed, your supply chain would be down for some amount of time. But if we take action and contract warehouse number 2, then we have a more robust supply chain to changes in events. This is the case where we want to find anomalies in the current supply chain data. We find a lot of times that customers don't really know exactly what they want to do with graph and supply chain. And a good first step sometimes is for us to pick through the data and find out where the treasures are. We go treasure hunting in your data. So right here we have a traditional sort of data science technique, a business intelligence technique for doing anomaly detection. And that simply is taking some of these metrics, some of this data you have about your supply chain, plotting it against each other, and finding the outliers. So in this case, we have average production times at a facility versus the worker productivity index at each one of these facilities. Each dot, again, would correspond to either facilities or it could correspond to timeframes. We easily see the outliers in this data set, and we say, investigate these outliers and try to fix whatever the problem is. Now, that works. A lot of the time that works. But we're more interested in solving for higher dimensional, more complex problems that you can't find with traditional business analytics. So using graph, once your data is in graph, you can perform a variety of new techniques that are better suited for detecting subtle anomalies that you would not be able to detect with the traditional business analytics techniques. So this is, I'm just showing one example here. On the right-hand side, we have a so-called graph embedding, where we cluster our information, we hope to cluster our information based on and we're getting into the weeds here, so bear with me, the spectral components of a graph. So the purple and yellow diagram you see is called an adjacency matrix of a graph. And the plot I'm showing there, the scatter plot, is simply a spectral embedding. And we see an orange highlighted blob there where we would like to investigate. And the reason that we're doing that is because those outliers have been teased out from the average, from the standard background behavior of the supply chain. Scott touched on recommender systems. So let me just mention quickly how that works. So we have a deep learning system which analyzes the information extracted from a graph. Again, on the left-hand side, I'm showing this is a hypothetical situation where we've extracted information about warehouse 11. Those are shipment travel times. We feed this through the machine learning, the deep learning network. And what we get on the output is an intervention suggestion. So we see red nodes in that left-hand diagram of warehouse 11, right? So maybe those are long shipment times is what that represents. And what we suggest on the output of this intervention, so-called intervention network, is three things: scored by both cost to the company and by revenue increase for the company. So the three options are staff up. That obviously that works, right? Your shipment, this thing is saying your shipments will increase by 11%, but it's going to cost you an extra $80,000 a year. Okay, so maybe that's of interest. You could do not, alternatively, you could do nothing. Your shipments won't increase and it won't cost you anything. That's a viable option. It has to be considered in a business decision meeting. And probably the optimal decision is to offer production bonuses to the current staff at that facility. So yes, your shipments won't increase as much as staffing up. We see a 10% increase as compared to 11, but it will only cost you $8,000 per year. That is what I would call an optimal solution. So that's what I have for you. I'm going to hand it back over to Scott to show you a cool supply chain demo.
All right. So for those of you counting at home, graph is good, ML is great. Then visualization plus those two really gets us to this next level, which is now we can change the game. We can do those actionable items. We can bring things to human beings that, believe it or not, are still very important in the process as we start to do these things. That's our goal. And that's where we can start to see now, whether it's on mobile devices, it's creating these links to the machine learning, which is have a human make a decision, start to understand where they go, and more importantly, in context of systems, show a human when they should care, and in some cases where the noise is, don't alert them when we don't need it. And that can start to bring rise to whether it's investigation or actionable activities. That's really what we're hoping to do and aspiring to do with the systems that we build with our customers, which is whether it's a risk score, it's the ability to do the clustering and the sameness, and then actually create an outcome back into the system. And these are just a few of the table setting visuals that we use, whether it's a traversal, which is the ability to get into a graph, and again, whether it's a product or a route or a shipment or a customer or those kinds of things. It's really all the same. It's something we refer to as a graph traversal, which is show me as I start to explore for what those looks like. And these are a few of those that we also see in the supply chain. This is typically referred to as a Sankey chart or a flow diagram. What we can see is everything from the source on the left to perhaps an interim where the manufacturing is done out to a warehouse or distribution center, all the way off to the right. And we can use these particular lanes. We can click on a store and then work our way back to the left to see where the supplier source is from, or perhaps we can see where distribution centers are, and we see down here in the bottom we can overlay things like routing as well. The next one then is a pure dashboard, which are KPIs or a histogram now within Graph, which are things that seem unrelated perhaps about when things were returned or tracking or impacts, those kinds of things, but they can be all put into one dashboard so that we can start to utilize those things again for our human partners. See another version of this, which in the upper left-hand corner may have the entire supply chain from supplier to store, and then allows us to then click on a section that might be red, draw our attention to it, and then drill into it. We can see things like tree diagrams in the middle for actual manufacturing in certain stores or certain areas where they might be. We can drill in, and then we can see impacts like weather as we see across the transport and analysis. And these are all visual representations. These are all meant as teasers for those of you at home that may be building systems. Another version here where we're looking for specific parts and again KPIs. You'll notice the timeline slider across the top. That's another very impactful and useful thing we can do inside of Graph, is this capability to collapse time, to be able to do large amounts of time in a very short, whether it's a visual and an extremely fast interface on the web. This one is now logistics or routing, where we can see impacts in red of things that could happen or where they may be stalled, and then things in white where we can find an alternate. And again, all of these are designed to increase that 1 to 10% in some cases. So whether it's cutting costs or driving revenue, all of what we've been talking about today is really bringing home that fact for the business case to be able to impact the business. Our last one here now is an idea of what we can do with people. Supply chains don't always have to be parts and pieces and customers. In this case, it's actually subcontractors that may have, whether it's training in certain kinds of things, or in the case of red, they may not be certified in certain areas that can also help us do that. But again, these are all designed to really sort of get the art of the possible across. Our last one now is something like a timeline, so we can start to sequence things that humans can understand. Perhaps they were violations or other kinds of things, and their score starts to escalate as we go through that. And there's more instances of now how we start to combine all of these together, whether it's scoring in combinations with our ML kinds of attributes, and then the items across the bottom that could be your OLAP or your other kinds of systems that we see as well. There's always a place for those current systems, whether it's SAP or those dashboards for reporting and Cognos and those kind of things. Typically, our applications are built with all of those. So with that, I was going to walk through a couple of applications to, again, sort of tease out the art of the possible. In our first application here, we start to see a worldwide, in this case, it's as much of the downstream or the operational readiness, if you will. In this concept, we're looking at aircraft. And it's as simple as several elements make up capabilities to maintain my aircraft. And what I can see now is I have different categories of carriers that may have different kinds of aircraft. There are human beings, there are the actual aircraft, there is the training that those human beings have, and then there are the depots or the supply centers that we have. And so what we see now is a very clear visual. We see a timeline horizon across the top that can show our peaks of values of readiness across the globe. And then as I click into that now, I can start to realize that if I'm a global manufacturer, I can start to see that certain of my support streams may be higher or lower simply by looking at those combination things. But at a macro level for executives, I can start to look at readiness in those different areas. And in this case, it's both an area and perhaps a product. I can start to then see simple information like what is my preparedness now for the wrench, which are the people, the airplane, which is now my equipment, and then the training, and are there other mitigating factors for what that looks like, and is my preparedness in this particular case is not high, it's actually low. So I start to see now a very simple user interface, perhaps for whoever it is that's going to be using this. Now I can drill in. So this concept of drilling into a graph, and now I want to pick one of those nodes, if you will. I want to start looking at what those things look like in different areas geographically in the United States. I can start to roll over things here and say, well, the reason why is because this particular aircraft has a series of things that are actually required, and we're a bit short, and in many cases we're back ordered. So that's the reason why we're behind that. I can also go to some of the other ones that are here, and I can see, well, it looks like mechanics are actually in good shape. So that's one of the things that's good as far as we do those things. Then I can actually drill in and look for the individual parts and realize, well, I do have a disruption for whatever that may be. I may have to go find now an optimized route to get that part out to where I am in the particular part of the world, et cetera. But now I can actually drill in to do that. And ultimately now we're tying this together with the human being, which is where are they located and what are their skills. But the goal of this now is to create an interface. In this case, it's typically an analyst, someone who's trying to look at readiness before we have an impact. But this is certainly one use case for how we can optimize a portion of the supply chain. In our second supply chain use case, we now actually want to look at simple routing for optimization. In our case here, we want to simulate an event. In this case, it may be a weather or a port strike, something along those lines. We start to see the dots, which are the supply centers in our example here. And our goal now is to optimize that to be able to save, in one simple case, might be hundreds of thousands, but over a course of a year, maybe millions. I can start to simulate that event. And again, I'm using a timeline slider on the bottom. I can create now what these waypoints are and perhaps what this blast radius is by this adverse event. And now again, I can go back to my old friend, the Sankey chart, and realize that indeed that is quite a disruption for what I'm going to do. And then ultimately now I can suggest via machine learning, what is my alternative path? And I can see down here in the blue, this is really going to save the day. I'll be able to not only get the parts and pieces there in time, but actually now start to get these other manufacturing runs in place to be able to optimize whether it's customer orders, but really sort of save time and money. And so with that, we have now seen a couple of art of the possible demonstrations. And hopefully now everyone is excited. But great, Scott and Graham, I love it. Where do I start? What we typically suggest to our customers is that regardless of where you are in your life cycle, so if this is a new supply chain optimization, whether it's again in any of those categories, or you've actually got something underway, we can help you, or you can certainly use this kind of a template methodology on your own, which is to assess where you're at. And if you haven't and you're still in that discovery, certainly creating a proof of concept to get a working version using graph and machine learning. In some cases, you don't have to have machine learning with graph, or in some cases, you can have machine learning without graph, et cetera. But the point of this is get a working iteration before you move to a full pilot. And that's really what our next playbook step is again, this punch list of whether you ask us to help you or you do it on your own. The key now is to be able to use those data sets. Typically with graph, you want to see the data first in conjunction with your early discovery activities, because sometimes the data is overwhelming. You may have a terabyte of data, and the question is, how do I do that? It's hard, and the visualizations may change as well. And so our tip here is that getting that data, getting your use case together early in a prototype are really the success factors for getting that true pilot that solves both business and technical value. These are typically now then the steps that we take along the way. Is you can use graph, we start to do some ideation, discover that data, really define now what that presentation may be, because ultimately we're building these for human beings. And then let's get that prototype to the users early. And I know the IT folks on the phone, we have to talk to our business users, but the beauty of what we showed today then is this is typically a very engaging process. It's a dynamic to see the visuals, and they typically get very excited when they can be empowered and part of the solution. And with that, we're almost right on time with our schedule. That brings our webinar to a close. We hope for all of you who joined us all the way through, we hope each of these were exciting and informative for you. Again, if you have any questions, Graham and I are always online and available for conversations. If you feel like your company can be assisted by anything we talked about today, we have no problem in sharing or resharing this webinar in more context with your business problem or your particular industry. But the goal and the takeaway here is that we help you solve big problems, and we really feel like this technology can help you get there.
Awesome. Thank you so much, Scott and Graham. Don't forget to submit any questions you have via the chat or the Q&A box. And you can find the Q&A box by hovering over your Zoom window, and it'll be right there at the bottom, Q&A. So to get us started, we do have a few questions already. First one is for Scott, it looks like. What industries work well for graph and ML?
It's a great question. It's funny is as online retailers and some of the bigger enterprises have changed, we originally had seen things like automotive, as we showed today, airplane, electronics manufacturers are certainly the ones that come to mind, but certainly the newer ones, such as whether it's an online retail company who actually has their own inventory, supermarkets, and those kinds of folks have gone internet as well. So it's pretty much anyone that has supply. We've even seen media companies that are actually tracking their supply, which are the electronic or the digital content that they put together in some of their newspapers these days. So it really, it's where people have these large contexts of parts and pieces, and whether it's at the source level or in the routing. So that's a long answer to it depends.
Awesome. Another one we have here is, what steps are taken to do a proof of concept when using ML?
Go ahead, Grant.
So the biggest thing we request is that we drill down, as Scott said, on a use case early, and we use some data to flesh out the idea before we start really diving into a solution. So we generally prefer to peek through an example of data from the customer and then start designing an architecture from there and working iteratively with the customer to really specify and drill down on that technique or that use case, and talk about the personas of the users, which users are going to be the ones who use it before we start really building anything.
Awesome. Graham, this is another one for you. We actually answered this during the webinar, but I figured you could give us an overview for anyone who may have the same question. Do you run any simulation before generating prediction?
So the question it applies to a wide variety of techniques and solutions. So the answer really is just that it depends. The answer I provided online was yes, for some solutions we do simulation. One example, and the one I mentioned on the chat box, was the case of using reinforcement learning to optimize supply chain. So in those types of solutions, in those types of settings, we do indeed use simulation, but even that problem can be solved using other solutions. So I can't answer it more than it depends.
That's fair. Okay, awesome. We have a few more questions here. So what kind of people profile do we need to look for to help us leveraging graph technology? Scott, you want to take that one?
Sure. I think there's two kinds of people profile this could be interpreted as. The first one then is the people as your customer. They don't really need to know too much about graph. It's really sharing the use case problem. The other element then is graph and graph training. We offer some training out on our website, both courses at nominal charge, $99 or less, to learn about the graph technology. And so as a technologist, you really have to have the hunger to be able to do that. And I think if you have some light SQL and that kind of a background, you're actually really in good shape to be able to help solve the business problem. But again, part of that is really understanding, a logical data model level is really what you need to be able to build a graph type of an equation. And then the concept of having the user be able to speak to you about their business terms. And that's really kind of both sides of the fence as far as how you need people to solve the problem.
What is the average cost of a machine learning based implementation, such as the example provided today?
So I can answer the high level and then I'll throw it to Graham, which is we typically offer packages that may start with an idea that can be in the $10,000 to $20,000 range, and certainly Graham can give you more details on what that looks like. And then we do, as we heard later in the PowerPoint, which is more of a pilot solution, which can be in the $30,000 to $80,000 range, where we can start to do more complicated versions. We can start to spin that up, and there may be some hardware involved. And then Graham, maybe a little bit more detail on what that looks like.
Yeah, again, depending on the solution type, occasionally frequently we use hardware accelerator tools. Like for instance, we use GPUs, and that costs money, right? So that increases the price a little bit if we're using a cutting edge technique. And as Scott mentioned, we shoot for a pilot project. We shoot for that 30 to 80 range.
Awesome. Here's a really good one about user interface. It says user interface has been a weak area. There are tools like keylines, etc. What is a good approach to start out, custom versus off-the-shelf tools?
Great question. If you go out to experoinc.com and you go to our graph gallery, out there you will see a couple hundred sample interfaces, and part of those are samples across all of them. So whether it's Link Curious or Keylines or D3, if you're just getting started and you do not have a project, I would highly encourage you to go look at the free softwares that are out there. And as you mentioned, they are not, unfortunately, tremendously detailed. The folks like Keylines offer a great product. Link Curious does as well. But those are paid for. So if you have an application, you now have to do a cost benefit to suggest, is that cost of the use of that tool worth your time to recreate the wheel, for lack of a better word? And that's only something that you can do. We highly recommend chatting with one of our experts to be able to suggest what we do. Now, we offer toolkits at zero charge to our customers. That's right, $0, because we're consultants. We share our toolkits, which are many of these customized time sliders, Sankey charts, those kinds of things. But as you use us as your partner and smart friend in this process, we share that with you. So that's how we make our money, is by sharing those kinds of things.
Awesome. Is it good to use a graph when we have data in millions of rows?
Great question there. So we're doing a large project with a government agency, and that agency is using billions of vertices and edges, and we are looking at incredibly fast run time. So millions actually is not really a very big of a problem. It seems like these days, every time you get a poster child of a billion nodes or more, it's even bigger. So we're looking at some now that are even more complicated, and when you look at some of these things, they're in the billions, kind of as a table stakes, if you will. So millions are pretty solidly in that same range for graph.
Awesome. We're about to answer the last question, so I just wanted to point out to everyone that in the chat, I submitted the link for our GitHub Graphs in Machine Learning, as well as the link to our graph gallery. If you want to go ahead and copy those down now before we exit out after this last question, go ahead and do that. Okay, so this last one says, you mentioned something about taking paper documents and managing them using ML. Can you explain this further?
Sure. The example that I showed, the image that I showed on there, was a two-part solution. One of the pieces was extracting the data from paper documents. The other piece, the second piece, was using some sort of aggregation system and content-based search to cleverly organize the documents. So the first thing is, yes, indeed, we can use some deep learning techniques to extract data from scanned images in several cases, in many cases. And the second piece, which is the really cool piece, is building content-based search and content-based imaging on your data itself. So the analogy here is you can search on Google for like images of horses, right? You type in horse and it knows what that is and it brings up images. So this is the same type of system. So if you search, you could search through all your documents for warehouse 37, right? And it would pull them all up.
Awesome. Thank you all so much for being here. We really appreciate it. Love the questions you're sending in. So if we didn't answer a question or you think of something later on, feel free to email us at info@expiroinc.com, and we'd love to talk to you further. Otherwise, this webinar will be online and emailed to you as soon as it's ready, and hope you guys have a great rest of your day.